Okay, it's time to get going. Let me share my screen and welcome everyone to this month's second Tuesday. We've got Larry with us today acting as our moderator. So if anyone has questions, please feel free to put it in the chat and Larry will interrupt me as I go to answer the questions. Today's session is turning guesswork into KPIs, key performance indicators, and establishing your daily E-factor scores. Great. All
Okay.
right.
Hey, Dave, we do have a question before you get
Yeah.
started.
Yeah.
KPI. There was a question on the slide. It says KPIs,
Yeah.
and
Yeah. KPI is a key performance indicator. So it's a way to judge performance of how the press room is doing in terms of quality. So more and more companies are looking at establishing what are called KPIs, key performance indicators, to help assess how productive or how high a quality the press room is doing. And this is from a print shop perspective, being able to qualify what the quality is of all the presses and all the printers is an amazing capability that all of our users rave about. So that's what a KPI is. Hope that answers that. If it doesn't, go ahead and ask a follow-up.
yes, it
So,
does.
in terms of how we typically go about this is we do recent ChromaChecker improvements. We've added a sales directory to ChromaChecker. We've had so many brand companies come to us and say, we're tired of auditing printers to see if they can print for us. We know that if they have ChromaChecker, they know what their level of quality is, and we can see their data. Can you just tell us who's using ChromaChecker? And it's interesting because I don't know if any of our other companies that do what we do this, but we've added a sales directory within our software, and brand companies can search using ChromaChecker for other PSPs, print service providers that are using ChromaChecker, and it allows you to get hooked up with brand companies that you might be able to do work for. So I encourage all of our users to use the sales directory capability within our software. Next, we've been talking about our packaging inspector for a couple months now. This is a version, or it's actually a tool in capture that's specifically for packaging. We haven't had anything like this before. We've gotten really great reviews on it. Many customers that have used some other programs are now using our packaging inspector, and we'll have some really great testimonials shortly. Um, Next month, we'll probably, or even before next month, we might do a special session just on the packaging inspector because it's ready. It's within 30 days of us making it available for all of our users that might want to use it. It is an upcharge. We haven't figured out what that is yet. I think we might experiment with it, let people try it for free, and then get the feedback of what people think the value is. It's not going to be a big upcharge. We're talking minor dollars here. Next is our artificial intelligence modules. We've added another module on troubleshooting. So right now, tech support and troubleshooting is built into ChromaChecker. It's the little person's icon in the bottom right-hand corner. It supports over 20 languages today, and there's no real need to read the manual because our AI agent has read the manual. So you can ask them virtually anything you want about ChromaChecker and they'll answer. And we've been working on this for a good 6 months now. We've been training it and it's been in production now for a couple months. So we know what everyone's asking and we refine the questions to make it better, faster, and easier. So please feel free to try out our artificial intelligence. Another improvement we've made in ChromaChecker is that when you're in the print inspector and you're in the timeline mode, so for those of you who know Print Inspector, this is showing you, uh, this is actual data of 220 plus measurements over however many days, maybe 220 days. And the purple line shows how accurate the printer is. The green line is how accurate the company wants the printer to be. You can see, for the most part, the purple line's below the green line, which is the E factor. And now you can hover on any of these measurements. So I'm hovering on the measurement that's over 8 E factor, and it's telling me exactly what the file name or what the date was when this measurement was done. So you can go in and take a look at it and see what's happening. So that's a new capability. We've also added many connectivity options with ChromaChecker now. It supports both a push and a pull architecture. We've been refining this over the last couple months, but this allows you to bridge your quality performance, i.e., what ChromaChecker is touting in terms of your E-factor quality performance, to your production speed or to your maintenance events that you have on your pieces of equipment. So this allows you to integrate with your MIS. And if you're looking at push notifications, we're using the Google Pub Sub messaging. And the flow is the print service provider or the printer feeds the data to ChromaChecker. ChromaChecker then pushes that data to the Pub Sub platform for a real-time push. Every measurement can be pushed instantly. You can have only failed measurements push instantly. So people have been asking, hey, I want to know the second my printer goes out of spec. You can do that now with this capability. Um, and then the security is it's only published with a schema validation, and it's best for automated high frequency data sharing across all printers, all platforms, all users. Now, we've had pull notifications for a while. This is using the REST API. We haven't marketed our API. Our big customers have all come to us and said, "Hey, do you have an API?" And we've said yes, and they've integrated it. As if any of you were at our color conference 2 years ago, one of our users from Shutterfly was showing how they've integrated our API with their production data, and he was showing it on his phone as a dashboard that they've implemented ChromaChecker with. So this is more pull-based access. So the data is fetched from ChromaChecker when requested. And so these are both exciting capabilities that we've added to our platform. Next big thing I want to talk about is our color conference coming up February 3rd through the 5th. As you know, all know, Printing United isn't doing a color conference anymore. And so this is now our 4th year of filling that void of no color conference. We've got 3 days, 2 parallel sessions, 4 tracks, a packaging track, a branding track, a sustainability track, and a ChromaChecker certification track. We've got a keynote speaker on the second day who is Andy, head of ISO 12647-2, talking about the universal characterized data set. This is going to be probably called Grackle 2026, and it's essentially the merging of the Fogger data set with the Grackle data set. And we'll have actual prints there. I've got some back here that people will be able to see the difference between Grackle and 2013 and Grackle 2016, and there'll be a lot of buzz on this and a lot of conversation. So hope you guys can join us for the color conference. It's in the Tampa, Florida area. You can find more information on this on our website. So now getting into today's presentation, from guesswork to KPIs, which are key performance indicators, establish your daily E-factor scorecard. So we all know If you don't know, you have to know. Waste kills profitability and sustainability. And I'm asking, do you leave it up to the operator to determine what is waste? Whether it's an offset press or a digital press, the operators, the really the person that sees it the second it's out of the printer. And most companies leave it up to the operator to determine whether or not what's printing is waste. That's that's a really hazardous way to do it because we know not all operators judge color the same. And and we want ideally we want all our printers set up to match the same reference, at least when they're printing on the same materials. But when they are, do you know which one's the most accurate? Which one, if we have, let's say, four printers, and this happens all the time when I um, teach the G7 experts class where we make someone a G7 expert, we'll have three G7 compliant printers, and we'll put the prints all next to each other, and they don't match. They have a shared visual appearance, but they don't match because we didn't try to make them match because G7 allows you to have a shared visual appearance. G7 never promises a match. It's a shared visual appearance. So now you've got three G7 prints. I've actually got them in my light booth here. Which one's the most accurate? And G7 experts typically look at me like a deer in headlights going, well, my G7 teacher never taught me that. Well, one of these, if we're aiming for Grackle, one's closer to Grackle than the others, or maybe two are tied for the closest. But don't you want to know which one's most right so you can then fix the ones that are less right to be more right? Because G7 isn't um, it doesn't mean it's sellable. Meaning you could have a G7 a compliant sheet and the customer says that's not close enough color for me. And so this whole idea of introducing accuracy into the mix here is really key. And here's an example. These two prints are both G7 compliant. But if you look at the tomatoes, I'm sorry, they don't match. And these are both G7. So having the ability to have a metric that defines how accurate each printer is, not only to the reference like Grackle, if you're printing on a number 1 paper stock, but also how close are the printers to one another. And there's a great article by Kieran Deshpande, who hopefully will be another key speaker at our conference. I'm still waiting for confirmation from him, but he published a document on sustainability. The link is here in my presentation. And he talks about color workflow optimization, reasonable tolerances using this metric that we call E factor, and validating prints. And so it's be great to quantify the color match of all your printers. And if we think of each dot here as it could be the same printer over time, or it could be different printers. On the left, we see 5 printers with no color control. They don't match. They're not consistent. They're just any way, any day. Then the second one, we have the printers are all calibrated and they're all consistent to one another, but they're not necessarily accurate because they're not matching the bullseye. Dart, they're precise, but they're not accurate. The third one shows they're all fairly accurate. They're all kind of around the bullseye, but they're not real close to one another. And then the fourth one is they're both precise and they're accurate. And this is typically achieved by doing characterization and color conversions more than just G7. So wouldn't it be nice to be able to quantify this level of difference in the printers? So if we take a look at the printers, not all presses or printers have the ability to print precise or accurate. If you look at the press on the left and the press on the right, we can guess which one's going to be more accurate, more precise. If we look at the consumable materials, what you see is a magenta ink from the same manufacturer on two batches of ink. Um, you're not going to have very good precision or consistency if your ink's going to vary by that much out of the bucket. So all these things play into how precise and accurate your printing devices are. And it would be really nice to be able to go in and quantify how precise and accurate printers are, because manufacturers don't tell us this. On offset presses and traditional conventional presses, a lot of the precision and accuracy is up to the skill of the operator, but it's also the maintenance and the level of capability of the hardware itself. Digital presses, it's very much dependent on the digital press in terms of what it's capable of. And so many people buy these presses without knowing these numbers ahead of time because, again, manufacturers don't publish this. But um, what we need to do before we ask, is the printer capable of manufacturing color that's going to meet my expectations? What we really need to do is, what are my expectations? So this is where the E factor exercise comes in handy. This is an exercise a ChromaChecker has, both a hard copy and an online copy, that allows you to quantify how close two colors have to be in order for you to accept it. Now, when I say two colors there, kind of has a connotation of delta E, because delta E is the difference between any two colors, two individual colors. But E factor is the difference between any two pages. And it's essentially saying that 95% of the colors on the one page are within that delta E of 95% of the colors of the other page. So what we did was, we have manufactured these printed um, um, E factor exercises, and we put 200 brand buyers through this exercise, having them compare two prints at different levels of E factor and asking them what they would accept. And 95% of the brand companies would accept a 3 E factor or less, which is fantastic. Anything more than 8, they wouldn't accept. So now at least we have the guidelines for what's acceptable. Now you need to do the same thing for your shop, because I've got shops that are 7 E factor and they run all day long and make money. I've got shops that are a 3 E factor, run all day long on hundreds of presses and make money. But trust me, the printer that's manufacturing color to a 3 is charging a lot more than the web to print printer who's doing a 7. The web to print printer essentially is getting all their data online, no proofs. People send them digital files, they print them, and you get what you get. And they can live to be a 7. Whereas the printers that I have that are manufacturing color to a 3, they have the occasional customers come in and look at the print and do things like this. So there's not a right or wrong answer in terms of what your E factor is, but you should have a shop standard for what you're trying to achieve. And then once you have this standard, then you can align your printers to this level of expectation. So if the printer has a smaller E factor than the customer, you'll have success, you'll make money. If the printer has a higher E factor than the customer, then the customer is not going to accept it and you'll lose money. And the same thing goes if you have two printers that are doing the same type of work for that customer. If these two printers have an E factor that's higher than what the customer's accepting, you'll lose money. So this becomes a really key way to quantify what's happening in your presses. And if we take that same scenario I gave you earlier, where we have no control, print anyway, any day, versus print accurate and repeatable, typically we find that people who just do G7 curves are the third bullseye over. And you can expect a 4 to 6 E factor on your prints. But if you do ICC profiles and color conversions to control how your printer's performing, then you can typically get down into a 3 E factor or less, which will help sell to all the top demanding types of customers in our industries. But doesn't mean you have to do full profile implementation for all your printers if your customers aren't a 3. This is why understanding what your customers' expectations are really critical in order to determine what level of E factor you should implement in your shop. Now, we have 3 ways for people to get started with ChromaChecker. And we're going to demonstrate these 3 ways. And it's essentially, first thing you do is you want to see and experiment what your E factor is. And I'm going to just quit out of the presentation here and go to our website and show you how easy it is. So I'm going to go to my ChromaChecker, and in my image exercise, we have a blind exercise. We also have an image exercise which shows you what's a 6. Right now, this is a 6. But if I go to a 3, you can see that's a 3, and it's substantially less. Now, what's interesting here is these 2 colors are a 3 delta E, but these images are a 3 E factor. And you'll see if it's go to a 1, you can see you barely see a 1 delta E, and you barely see a difference with the images. Whereas if we pop up to an 8, it's an extreme difference. Hence, very few no print buyers would accept an 8. Almost all print buyers accept a 3. And then you have the really picky ones that are down here in a 2, where you could be a 2, but you better be controlling all of your printers and your light booths and your instruments, which I'll bring up. We are publishing now. I'm sorry, I don't have the link, but ask me and I'll get it for you. We're publishing labels that you can print on your printers that allow you to stick these labels on your instruments to show that the instruments have been chroma checked, on your light booths to show that your light booths have been chroma checked, and on your printing devices to show that your printers have been chroma checked. And so this allows you to essentially show that all your devices are being checked, and our users now are getting these chroma check. It says, we chroma check to you these pins. If you were a user and came by our booth at Printing United, you got one of these pins. And if you're a new user, you get the pin when you order ChromaChecker. So these are ways that we're helping people educate everyone on what this all means. Now, this is great to show you what a 2 looks like versus an 8, but some people just think, oh, I need to be a 2 because that's what I've heard. So that's why we have the blind exercise. The blind exercise doesn't show you what the number is. You say start exercise, and then it says, hey, don't judge if you see a difference, because you're going to see a difference everywhere. Judge whether or not the apparent difference is acceptable, i.e. sellable. So this is going to take at least 9 decisions. So I'm going to go through it fairly quick. And I'm going to say this level of difference is not acceptable. This level of difference is not acceptable. This level is not acceptable. This level, definitely closer. I'm going to accept this. I'm going to accept this. I'm going to accept this. And now this I'm going to also accept. This I'm going to accept. And here's my 9th example, accept. And it comes up and it says, hey, your E factor is a 3. So based on how I answered those comparisons, it says I'm expecting very high quality. I need to be very particular on what printer and printing device I use to reproduce my work. Very few printers and printing devices can maintain an E factor of a 3. Excellent training, equipment, da 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 da. So if I would have answered it differently, I might have had a 5, I might have had a 6, and then it has a profile of what a 5 and a 6 looks like. So now, once you know what your E factor is, then the next step is really checking to see what your printer is capable of, what the E factor is of the printer. And so the E factor of the printer, we recommend you take this file. This is our project accuracy to Grackle, and you print it on all your printing devices. And then you measure the target on the printing devices and you enter in what the E factor is of that print. And you can then know the device with the lowest E factor is the one closest to Grackle. So here I have some samples. I have this printer, which is a 6.7. I have this printer, which is an 8. I have this printer, which is, I didn't write it down, but I want to say it's like a 6. And and then I could actually hold it next to my master, which comes as part of the E factor exercise, shows me what Grackle looks like. So then I can put the Grackle print up against the other prints and just really see how close they are to Grackle and see if the numbers really show what my eyes show me is the one with the highest E factor is the one that's visually the most different from the Grackle print. So this is really educational and it helps you show management and show people who don't understand color what this means. This is how far this one's off. This is how far this one's off. And it helps you prioritize. Now that I know that this one is the farthest off, that maybe I need to update the profile or I need to update the curve to bring that device closer in line. So let's go to the getting started page. So in ChromaChecker, there's a getting started page, and let's go ahead and leave the presentation and show you this. So I'm going to go to the ChromaChecker page, and you'll see there's this getting started. And this getting started, tomorrow this should be redesigned. Our development team's in vacation today. So this is what it's going to look like. Let me show you. This is what it's going to look like. So you'll have 3 options. You actually do have 3 options today. It's just not super clear on that last page. But if you have existing measurement data, like a P2P or a proof verification bar in a CGATS, in an SVF, in an XML, you can upload it directly into ChromaChecker, and ChromaChecker will tell you what the E factor is. Or if you have your own instrument, you can download our capture software, which is the utility that drives many of these instruments, and print your own targets and measure what they are. And then we also have more advanced projects, which gives you the ability to check gamut and proof verification and brand color, spot color verification, all these types of things in the projects. So what I'm going to do is I'm going to go ahead and show you how you can upload data to ChromaChecker. So I've just clicked on my upload data and I've got some old P2P data here. You can do five at a time. In fact, let's actually do a couple at the beginning of the run and a couple at the end of the run. So I'll do these five and we'll open. ChromaChecker automatically takes these five files, uploads it, and it says, hey, these are between 8.6 and 10 E factor to Grackle. And by the way, none of them are G7. And by the way, only two of them have all the CMYK values are within the desired delta E, and all the RGB, the red, green, blue overprint colors are within the RGB. And I can go in and look at any of this and I can see exactly what the data is. And I can see my CMYK datas are at the right value. It even tells me if they should be adjusted, how I should adjust it. So the cyan is a 2.5, but if I go up 13 points of density, it'll go to a 1.5 delta E. Shows me the dot gains, shows me the gray balance and the tonality. And if I go back to measurements, I can even compare, if these were done on five different printers, I could compare printer one with printer five by saying compare, and it shows me there's 6.2 E factor for one another. So this printer's 8.6 E factor. And this is kind of scary because this isn't two different printers. This is the same printer over 400 sheets in the press run, and it's 6.2 E factor difference. And part of the reason why it's 6.2 is one was on the left side of the page and one was on the right side of the page. But over 600 sheets on a press run, you wouldn't normally expect 6.2 E factor. But that's the level of precision that this press that this data came from is running at. So again, extremely useful because, like I said, 6.2 is unacceptable to over 60% of the print buyers out there. And if you're pressed on the same run between the 100 sheet and the 400 sheets, so it's actually 300 sheets of difference, but one's on the left side and one's on the right side, so the press isn't very even, that can be a problem. So again, just really powerful capability here. Now, if I go back to the home page and go back to getting started, you can also use your own instrument and download the software to use a trial, or you can start and sign up for your free account. If you sign up for your free account, then you'll have the ability to have your own version of Capture. And the way Capture works, I've just launched my Capture here. It's connected to my i1. It can connect to like 12 different instruments. I could just show you here. So it supports spherical instruments, it supports gloss meters, it supports XY instruments. I'm uh, I'm going to it supports plate readers, the variable spectra 1, the Nix spectral 2, XY tables, so forth. I've got it just hooked up to my i1 right now. I don't have it to my IO or my ISIS or my exact. I'm going to say connect to the instrument. And I've actually got uh, a print here that I just printed out of my printer. Make sure it's calibrated right. And I've printed this over the last few days. So actually, I've printed it over, I think, about a week. We can look at the actual dates. But you'll see I have multiple of these printed. Because E-factor not only helps you see what the accuracy is, but it also helps you with precision. And what I'm going to do is go to my HP laser and choose my target, which is this target here. And it's saying initializing. Let's go ahead and make sure it's, I did see an error. related to my instrument here. So let me go back and see if we can make sure my instrument's working okay. So as I log in, I've got it programmed to bring me to my quick checker, which we'll see in a minute. Quick checker is more for spot color checking, but I'm going to go to my print inspector, which is checking for consistency and accuracy. And within the print inspector, now I've got the ability to take this target and measure it. So you'll see just how quickly I can do this. And I'm taking and reading the first row, right to left. And we'll see it fill in there. Now I'm doing the second row and I'll go left to right. Then we'll do the third row and we'll go left to right. And then the last row, right to left. Now, this target that I just measured, I can use to iterate a G7 curve. And you can see here, it's a 4.9. I've allowed myself a 5, so I'm right on the edge. It's acceptable. It's acceptable because I've asked for a 5. And if I look at my timeline, I can see in my timeline that I started measuring on 11/30, so about 12 days ago. And what I did with ChromaChecker was I set it up for a baseline. So when I first profiled the device, or when you first curve a device, is when it's going to be most accurate. And so you set that as a baseline, and then ChromaChecker will not only check the accuracy of how accurate the print is printing to Grackle, which is represented by this purple line, and you can see it was 4.1 to Grackle. It was 0 to the baseline because I built that. Now over time, now it's 4.3 accuracy to Grackle, but it's 4.9 to the baseline. So the printer has drifted 4.9 E factor in about 12 days. Now, it's my color laser printer, and it's probably 30 degrees colder today than it was 2 weeks ago where I'm located. So it's no doubt that the laser printer has changed the way it's manufacturing color, hence this red line going up, and it tells you, hey, it's time to reprofile it. There's no guessing here. Um, but it's very useful to know that type of information. And if I go to the cloud, so I'm going to actually log in and look at this data on the cloud. So I'm going to go to my login, and let's go ahead and go to my print inspector. Look at that. Now, we'll get back to the print inspector. I was just going to show a different way that this shows this trending of the file changing as it is going over time. So that is how I can check for the consistency. Now let's go back and let's actually add some more data. So I'm going to go out and import more data into this ability to upload data. And we're going to take this data. These are 5 HP printers. And so I'm uploading these 5 HP printers, and you can see these 5 HP printers, one of the HPs is a 5 E factor to Grackle, The other one's an 8. The other two are about 7.8. So again, it helps me see how close this HP 3500 572 is the closest to Grackle. It's not G7. So if I measure that target, like let's say this target that I just measured, this is the one I just did a couple minutes ago. If I wanted to take this target and make a new G7 curve based on how it's printing, all I have to do is hit that G7 button. It shows me the G7 data, showing me the tonality's wrong. The gray balance is actually right. But I can then say calculate. It'll calculate and fix the tonality and keep the gray balance good and make a new curve for me in whichever format my workflow supports. In this case, it exported a CGATS file, which I could pull into my Caldera RIP and force my Caldera RIP to go into a G7 state, even though it didn't print this in a G7 state. And it would naturally, usually bring the E factor down because it'll make the printer more accurate. If you have a print,
Dave, there's a question
okay, if you have a print
about
factor, it will save that format. If you have EFI, it'll save that format. So it supports all the different digital presses. What's the question?
what if you wanted to do an ICC profile rather than a G7 curve?
Great question. So you'd use this target here. This is what we call our CC 400 target. And it looks like this when it's printed. And we also support the IT875 if you want to measure 1617 patches. So we have a number of profile targets that you have that you can measure, and then ChromaChecker will build an ICC profile for you. So yeah, no problem building profiles or curves. It's just dependent on the target you're using. Now, this target's great because if I want to do a color match, um, in fact, let's do a color match at this point. So this target was used to build an ICC profile, and I did it 2, 3 weeks ago. And the data I just measured showed you it was 5 E factor different from how it was before. So if I'm going to now, let's say I want to find a color that's going to, or I want to print a color on my printer that's going to match this color here, even though my profile is not very valid to how the printer's printing right now, which that baseline just showed me, I'm going to do it anyway because ChromaChecker has the ability to iterate the CMYK values as necessary to get a good color match. So we're going to pop into our quick checker here, and I'm going to measure this color with my I1. I've got my white blacker here. And so now the purpose is I want to match this color on my printer. So I just measure that color, and ChromaChecker automatically calls it green beige 1609. Well, I'm going to go ahead and save this file in my assets. So I'm going to save it to a palette that I've got called Sony. And we're just going to call it beige. Okay, I'll call it beige. And we're going to save it. Now that it's saved, just like I could do with any saved Pantone color or any other color, I can go ahead and click on Start Color Match. And I'm going to come over here and say my printer's CMYK printer. And I'm going to choose that profile that I built with ChromaChecker 2 weeks ago, that even though the printer's moved 5 E factor, it's still okay because ChromaChecker accommodates that. Now I'm going to move to my Sony palette, and I'm going to, now, if I was going to try to match the Sony orange, ChromaChecker is saying my HP laser can get to a 6.8 delta E because it's a bright orange and the color laser on uncoated paper can't do it. It's physically incapable of making this orange within a 6.8 delta E, which again, I can show you what a 6.8 looks like using our that exercise you saw earlier in the presentation. But luckily, I'm going to do the beige. And when I do the beige, ChromaChecker is telling me I should be able to get it to a 0.2. So I'm going to say, great. So print my PDF of this beige color. And now it just put this file into my capture folder. And I'm loading it up so you can see it here. Here's the beige. It was just created a second ago. Here's the reference. Now I'm going to print this out on my printer. And so in a second, my printer just woke up. You'll hear it buzzing in a second. Here it comes. And I'm going to get that printout. Now, before you do a color match, like I'm doing now, you should be checking the consistency of the printer. And you should be using a target like I showed here to check the consistency, because ideally you'll make a lookup table for the spot color that you can drop into your RIP, your Harlequin RIP, your Print Factory, your EFI, what have you. And you'll want to know how often you need to update that lookup table by doing things like this if the printer drifts. So now I just measured this color, and in ChromaChecker, it shows me that match is a 1.9, which frankly, I'm a bit surprised because my printer's off by quite a bit from when the profile was built. But I'm thrilled that this color is a 1.9, but I want it closer. So I'm going to say print another PDF. So now on my desktop is my second PDF. So I'll put it next to the first one. You can see here's the first iteration. Here's the second iteration. So you'll see the one before doesn't have a second iteration. So now we're going to print this on my printer. We'll put this one off to the side. And you see it tweaked the CMYK value. It took the cyan from 17 to 19. The magenta pretty much stayed the same. The yellow it brought down a couple, and the black it, because it's only needing to make a small change here. And so now here comes the next print. Okay, here's the print straight out of the printer. I'm going to move this so you see the result, put it on the sheet, hot off the press, and up it comes. And it tells me that's a 1.8. That's a little surprising to me because it didn't get a whole lot better. But now I'm kind of measuring across the sheet just to see what the consistency is. There's a 1.1 over there. So let's do one more iteration here. So I'm going to say, let's print the PDF again. So I'm going to go ahead and grab that. And you'll see now this one has the previous adjustment on it. And it's 11:58, 51. Let's print this. Go. And let's see if we can get a better value. Now, I'm going to show you something in a second, because if you look at these prints really closely, I think my printer's kind of running out of toner. It's not real consistent across the sheet, which greatly affects the accuracy that you can get out of this type of thing. So here's my new sheet. Let's come back here. Let's remeasure it, see what the value is. And it's showing me it's a 1.0. Okay, so for this printer, that's probably pretty good. I mean, it's really good, frankly. So at this point, I could just say, take the LUT, make a new LUT, call it color match LUT, today's date, and it's all done. Now I can load this LUT into my workflow, and I'm ready to go. Now, just for kicks and giggles, I'm going to take this last sheet that I printed out and I'm going to do a start variation on it. And I'm going to measure multiple places on the sheet and just see how consistent this print is printing this color. So as I'm moving my instrument around the rectangle with the square in it, you can see that the peak delta E is 0.86. Now, it's not terrible. I've seen worse. And you can see the amount of variation that's going on the sheet is about a 0.72 E factor. So useful to know because I've seen people print out brand colors and they're like, this is my brand color. And when you do a start variation and you look around it, it's 2 delta E difference depending upon if it's on the left side of the sheet or the right side of the sheet. So just showing off some of the capabilities that you can do in ChromaChecker for both process to ensure precision and accuracy, and then spot to get best color matches for colors that you need to hit. So you can do all this with the trial, so you can see what is going to happen. This I demonstrated live for you in terms of how it looks. This is the target that you ideally want to print on all of your printers. And then, like I mentioned, and you saw here, you'll have these printouts and you'll have one printer's a 2.1, one's a 4.6, one's a 5.6. And what this means is it means how close each one of these is to the Grackle bullseye. So you've got your Grackle as the bullseye, you've got the large format at 3.9, the offset at 4.6, the proofer 2.1, digital press at 5.6. So the digital press is the one that's farthest off. So that's the one you might want to update the profile or update the G7 curve and get it closer. But also, you can quantify how close each of these printers are to one another, which I don't know of any other program that does this. So if you're doing the same job on a digital press as the large format, the fact that the large format and the digital press are 7 E factor different from one another, I can tell you the customer's probably going to reject that, especially if the two pieces are going side by side somehow or in the same packet. So these are things to help you understand um, how using E factor as a key performance indicator on how your presses are printing is really important. And not only does ChromaChecker tell you that printer A is different from printer B, but here's a scenario where I was comparing a Zycon with an Inca. It's telling me the difference between the substrates is greater than 2, and they're actually 6.6. So the substrate difference between these two prints is 6 difference. It's no wonder the color on the substrate is different, but ChromaChecker has the ability to find a best match substrate. And very soon, we've got access to a API that's going to one of our partners' websites who has over 4,000 substrates documented in their cloud. And we're going to be able to access those 4,000 substrates to give you a best match. We're not there yet. This will definitely be there at the color conference. We'll be showing this feature at the color conference. But now imagine, and by the way, it will also allow you to source the substrate. So if the substrate, if you're in North America, it'll only show you substrates that you can buy in North America. If you're in Europe, it only shows you substrates in Europe. So in this way, if you can find a closer substrate for the printer that you're trying to match, you'll automatically be able to get the color closer to one another. These are ways that we're implementing ChromaChecker to make it easier for you to match color. So register the trial is the highest level of capability you can have with testing out our software. You'll have your own account. Your data will go into the account, and then you'll be able to do all of these types of comparisons. And then it's all a matter of educating the operators in terms of once you've decided what your company E factor is, then you tell the operators. And when the operators print and then they measure, they'll get a green if it's okay, they'll get a red if it's not okay. And this is what the operator sees when they measure, as you saw when I was measuring in capture, shows you where you are in the bullseye. So really easy for the operator to see, oh, I'm 2.2, I'm allowed a 5, I'm safely within the allowed zone. Whereas if it's out, here's the red dot outside, it's an 8.4 on 5, and it's telling you, hey, you're out of spec here. And we'll even go as far as telling the operator if they've got the wrong paper loaded. Or here's an alert where the magenta nozzle appears clogged. We we've implemented technology so that if you've told ChromaChecker that this is an inkjet printer and it sees that one of the solids and the tone ramps low across the board, it'll come back and say, hey, it looks like your magenta nozzle is clogged. Please clean it. And you even have the ability to hook in where the PDF or the website hook is to learn how to clean the nozzle with an Arizona versus an Inca versus a HP. So this is key because one of the biggest challenges facing our industry is trained personnel. And we know that most of the trained personnel that are working on digital presses right now were flipping burgers 2 weeks ago. So the more we can help the operator fix the color problem themselves by learning how to clean a nozzle on a given ABC printer and get that printer back printing production, the more valuable it is to the company. This is a key slide showing minimum quality requirements. Every manager wants fastest throughput, but there's a cost, and the cost is quality. So you have to decide what the lowest quality level is to maximize that throughput. And then once you have ChromaChecker set up, ChromaChecker can build these automatic E-factor reports that go to every manager in the organization showing how their devices performed last week. So this is a real report from a company. The purple line is the company average. The red line is Indiana. The blue line is Arizona. And it's an aggregate of all their presses in Arizona. So each of these facilities has multiple presses. The top manager just wants to know that the facilities are doing okay. The manager only gets the average with their plant. They don't see how the other plants do. They can see if they're above the line or below the line, and then they get a line listing of their performance of E-factor performance of all their printers. So they know which printers are operating the worst and which ones need to be fixed to bring them up, to bring up the overall company up to a higher level of quality. It's all about using E-factor as a key performance indicator. This gives you a real-time performance. So we have companies that take this and put it on a plant wall on a 60-inch monitor. And everybody in the plant looks up at it and sees to make sure their printer or their light booth or their instrument or their plate setter or their substrate is green. Because I've just talked about 6 different positions within a plant that are all responsible for colors on this dashboard. That means those 6 different people or those 6 different jobs are all looking up at the dashboard, and it's a peer pressure thing. They want to make sure that what they're responsible for is green and not red. And for this reason, owners of print shops have hugged me because the whole concept of finger pointing goes out the window. They say before ChromaChecker, every employee had a paddle and they'd hit the other person over the head with it. After ChromaChecker, everybody understands their paddle is used for doing this. They all have their own responsibility, and the boat's moving forward, and the blame goes away. So, in summary, move quality from feel to fact. How can you argue with this? Quality from feel to fact. ChromaChecker puts facts into your prints. It creates automatic reports. It helps you understand how accurate each printer is, helps you fix the worst one. It turns your production floor to a data-driven, accuracy verified shop. It's easy to train digital press operators on this. It's easy to know when your curve or your profile needs to be updated. No more guesswork. It allows you to easily get your printers consistent and aligned. Hopefully the color match demonstration showed you how easy it is to know whether or not colors can be made on the printer, and if so, how fast it can be done. And I didn't mention, if you have 30 colors or 3,000 colors to do, and you have an automated device like a i1, an ISIS, or a Miro 9, ChromaChecker will automatically build the layout of the patches. I was just doing this with Best Buy earlier today for demonstration of a customer. So I have the Best Buy targets that it printed out on a target that my IO measured, and it iterated all 18 colors on each print versus just one color. So very powerful capability here. So with that, I encourage you guys to sign up for our color conference. Anyone have any other questions? Are there any other things that came up, Larry?
You can conclude, Dave. Very nice.
All right, well, that I'm at my time, so I appreciate you guys attending, and the recording for this will be available probably hopefully tomorrow afternoon, if not the next day, because I know there's European vacations. But I hope this was helpful for you, and I hope you make the motivation to actually try ChromaChecker and see what your E factor is and see how well this works into your environment.